Number 1, photosynthesis. Photosynthesis. Photosynthesis is an extremely important chemical process that occurs on Earth. It is the main factor in the sustenance of plants and life on Earth as a whole because it transforms the unneeded carbon that we exhale into oxygen, which is a substance that all animals need. So the formula of photosynthesis is 6 molecules of CO2 plus 6 molecules of H2O plus light, then goes through the whole process and gives us products of a 6-carbon sugar and oxygen. So photosynthesis occurs in the chloroplast of a plant, which is also the same place where the green pigment of all plants are made. In the first stage of photosynthesis, 6 molecules of water and light go through the thylakoid of the chloroplast and produces oxygen and an energy called ATP. Then in the stroma of the chloroplast, the 6 molecules of carbon dioxide transform into 1 6-carbon sugar. So out of all that work, we got 2 products from 3 reactants. The reactants are 6 molecules of CO2, which is carbon, 6 molecules of water, and light. And then that's the products that we got is 1 6-carbon sugar or glucose and 6 molecules of oxygen. Number 2, digestion. Eating is a very important task that people do every day. In order for our body to reap the benefits of the food we are ingesting, it has to go through digestion, which is a very chemically based process. As soon as you place food into your mouth, an enzyme called analase automatically starts breaking down sugars and carbohydrates to help make digestion easier for your other digestive organs, such as your stomach and large and small intestines. Then, when the food hits your stomach, hydrochloric acid, which is a very strong acid that actually is 2 on the pH scale, reacts and breaks down your food. Then various enzymes split fats and protein molecules so they can be absorbed and distributed through your bloodstream.
Well, I'm Brianna Johnson's cousin, and I'm here to tell you about how chemistry aids me in my life. I personally love Pop-Tarts, so I believe that, the reactions that are necessary during Pop-Tart digestion, even though they are technically biochemistry, that chemistry just aids in breaking down all the glucose and the lactose and all the delicious sugars and properties of the Pop-Tart that I would not be able to enjoy without chemistry.
Okay, that's pretty nice. Number 3, cleaning. Cleaning is another job done all around the world by all types of people. Whether it's your body or your house, you clean it to help prolong its health and make it look better. Little did you know that cleaning has a chemistry background. First off, oil and water do not mix. This is because water is polar and oil is nonpolar. This is a problem. In order to successfully clean yourself or something, you need something to break this barrier. This is where soap comes in. Soap molecules are interesting. The head of the molecule is hydrophilic, which means it likes water, and the tails are hydrophobic, which means it hates water. When the soap hits the water, the hydrophobic chains attach to the oil and the hydrophilic heads go into the water. An emulsion of oil and water is formed. Then the oil particles get suspended and separated from the object at hand, and everything's clean. Number 4, rust. Iron is both a metal and an element. The symbol for iron on the periodic table is Fe. And when water and oxygen meets iron, the water combines with the carbon dioxide in the air and forms a weak acid, an electrolyte, that dissolves the iron over time, and the oxygen helps release the electrons and converts the metal cation into the form of rust. Number 5, the food processing industry. When you look into your pantry, what do you see? Cans? Boxes? Plastic wrapped foods? Majority of your pantry contains already processed foods. Processed foods are foods that have been altered from its natural state, either to prolong the duration of their freshness or make them easier to use. In order to make these foods stay fresh, you have to have a certain environment for them to live in. And there is a whole industry dedicated to this. This is the food processing industry. Whether it is by canning, freezing, curing, or smoking, the people who work in this industry must know about the chemical makeup of these certain foods and what to add or what to do to these foods to preserve their freshness. For example, many of the fruits and vegetables have ethylene, which is a hormone that accelerates the ripening process in these fruits and vegetables. So in order to combat these processes, these fruits and vegetables are usually canned with water or syrup, or they're pickled. And that's the food processing industry. Number 6, cooking. When you cook, many chemical reactions can occur, especially when you're mixing 2 or more substances, heating substances, or even cooling substances. Let's use cooking meat as an example. Majority of meat is animal muscle, which is 75% water, 20% protein, and 5% fat. Meat contains myoglobin, which is a protein that stores oxygen in red blood cells in red meat and even chicken, but to a lesser amount. It is very similar to hemoglobin in humans. When these things are being cooked, the myoglobin reacts to the heat used to cook it and oxidizes it, which causes the color change, which is pink to white in chicken and red to brown in red meat. Also, much of the water is lost, that's why the chicken is seen as smaller, and many of the protein strands in the chicken or red meat denature or break down. 7. Cellular respiration. Cellular respiration is a process that releases chemical energy from sugars and other carbon molecules to make ATP when oxygen is present. This process occurs in the mitochondria of animal and plant cells. There's a formula to this. There's 2 reactants and 3 products. So the reactants are glucose plus 6 molecules of oxygen. And when they go through the whole process, we have 3 products. That's 6 molecules of carbon dioxide plus 6 molecules of water plus ATP. Before cellular respiration even starts, a process called glycolysis has to occur, and this process splits glucose into 2 3-carbon molecules and makes 2 ATP molecules. Then cellular respiration really begins with the Krebs cycle. In this cycle, molecules are made from glycolysis, go through the matrix of the mitochondria, and ATP and 6 units of carbon dioxide is released as a product. Then through the electron transport chain, the energy made from glycolysis and the Krebs cycle head into the inner membrane of the mitochondria, and ATP and 6 units of H2O are released as products. Number 8. The human body as a whole. The human body is made up of many different cells, organs, and organ systems. But when you look at the human body on the molecular level, it is made up of 10 main elements. 65% of it is made out of oxygen, 18% carbon, 10% hydrogen, 3% nitrogen, 1.5% calcium, 1% phosphorus, 0.35% potassium, 0.25% sulfur, 0.25% sodium, and 0.05% magnesium. Number 9. HVAC. The acronym HVAC stands for heating, ventilation, and air conditioning. This job is an example of chemistry in the industrial setting. These technicians have to work with many coolants and refrigerants which contain many chemicals, both toxic and non-toxic, which are responsible for taking the hot air and cooling it. The V in HVAC does stand for ventilation, so they need to know about the different elements in the air and their concentrations, as well as the bad gases that are spread airborne, to try to keep the air as pure and safe as possible for the people.
Yeah, I'm Brianna's uncle, and she told me that a chemistry teacher asked her to ask her family members how does chemistry impact into their lives? Well, for me, I'm a technician. I deal with different chemicals, especially refrigerants. As a parent dealing with household goods, chemistry plays a vital part because we have to know what texture in terms of foods, salts, um, even cleaning detergents, the type of chemicals that they do have, and the conditions that they has to be used. Also, some of the chemicals could be very toxic, could be very lethal. So when it involves hazmat, we also have to read the labels and know what we can use, and where we can and or we cannot use it. So again, chemistry does play a vital part in our lives as a family. Thank you.
Number 10, love. Love is something everybody goes through. Whether it's platonic or romantic, this great feeling releases many chemicals inside of your brain. I will be talking about the stages of romantic love. First, you have initial physical attraction. During this stage, things like flirting, touching, and gazing into each other's eyes are very common. During these acts of affection, the two sex hormones of estrogen and testosterone rise. Then you actually fall in love, and you get that butterflies in your stomach feeling and loss of concentration on anyone else. These two things come from dopamine, which is the pleasure or feel-good chemical. Another chemical called norepinephrine helps bring a natural adrenaline, which causes those nervous butterflies and sweaty palms. Serotonin is another chemical which controls unruly passions and mood swings and helps you feel balanced and in control of your life and relationship. The third and most final step in love is actually staying together with the person that you're feeling. There are 3 chemicals that your brain releases at this point. Oxytocin, which is the cuddle chemical, which solely makes you just bond with people. Endorphins, these are biochemical compounds that actually help your physical health when you're emotionally stable. They enhance your immune system. And vasopressin, which is the monogamy chemical. This is a chemical that helps you get attached to one person and lose interest in anybody else.